Hello everyone. Today we are going to look how to control double acting cylinder in direct control. Um, in the previous video, we looked at basic control of double acting using direct control. So firstly, the difference between indirect and indirect control. A direct control, we are just using um, one control valve to control directly our cylinder. And indirect control will be using to control valve to control our double acting cylinder. Now, one control valve will control another control valve that control the cylinder. So hence it is called indirect. So we'll use this basic circuit that we have now here, that we have designed in the previous video, how to control it, a double acting cylinder um, direct using direct control. So now let us look in direct control. As I've said, we'll need another control valve that will control this control and valve that controlling a cylinder, and then let's make it in direct control. So we look for um, a prepare tool, and also it should have a push button. Please check the introduction of Fluidsim videos for you to see the basics, because now we'll be just moving forward, um, not showing you how to do this. We just designing. This is a trip by two. Now remember, we are this control valve need to control this one. So this one is no longer a push button. We double click, we remove a push button, we scroll up, choose blank. So now it will be pneumatical controlled. Then we connect it with this one. This will be a piloted control valve. This is a piloted control valve. This is the main control valve. So indirect, we have a piloted and the main. So the application should be the same. If we push this push button, the cylinder should extend. When we release the push button, the cylinder should retract. So let's apply pressure into port 1 and port 3 exhaustion. And also for us to note that I've mentioned that some books they don't use numbers as the software. Some books they use alphabet. This will be pressure, this will be an R for a return, or a T for a tank if we are using most cases, if we are using hydraulics, where it indicates that this is the return to a tank. So now, as we have connected it as it is, it push button with the return spring. This one it's piloted, this one is main, it's controlling this one. So you press play. So this is the pressure. As we can see now, currently we have pressure on the side that's causing our cylinder to retract. So now we're controlling this control valve to control this one, which this one is piloted. This is the main valve. So we press the push button, extend. As you can see, when you press the push button, the valve actuates, and then the piloted control the main one, and then it extends. We are no longer controlling this one using a push button. It is controlled by this piloted valve. So this is what we call an indirect control. This is how you use it. This is how you connect it. This is indirect. So this is the basic control of a double acting cylinder indirect control using mainly just only pneumatics. Let us see now how can also we control our circuit electrically and what is called electro-pneumatic. Now, to do that, we need to have an electrical circuit or an electrical control circuit that will have a push button. For us also to achieve this, we'll need to have a relay with contact and solenoid. So now we double click here. We are changing this now. It's no longer being controlled or actuated manually. It will be actuated uh, electrically, which is we select solenoid, and then we're still going to have a return spring. We say okay. So as we can see here, it's no longer a push button, it is a solenoid. So to control this electrically, we need to design it. Our circuit will need a 24 volt electrical control circuit and a ground or a zero. Now, I said we will need also a push button, a relay, push button. Let us have these are contact or make switch, and we need a relay. This is a relay. This is our push button, and also we'll need a solenoid. We'll need a solenoid for us to be able to control this. Then remember, we just press a push button. This should actuate and then extend our cylinder. So let us connect this. I'm just drawing the basic one. Later I will show when we are doing more complicated circuit how to latch the circuit, but for now I'm just designing a very basic one that will enable us to achieve what you want to achieve. Remember, you just press a push button, you release it, retract. It's and then this is our relay, our solenoid. Connect to this contact and this to here. Okay, let me connect it here. Now to label this, it's very important to make sure that you label it correctly for software to be able to read what you are trying to do. This is our relay. We name it K1. Enter. And this is our contact. We name it K1. Enter. So what actually saying here, this is our coil. When this coil is energized, this contact will close. And this is our solenoid. We name it Y1. Okay. Then now this one, we need also to name this one Y1 so that when this coil is energized, then this contact will close, and also we activate this Y1, and this is Y1 to cause our control valve to actuate. we double click here. We also call y1. So make sure your labeling is correct. Once you label this one incorrect, your circuit won't function. Okay, we press play. This is our circuit. This is our electrical control. This is our push button. Our application should be when we push a push button, our cylinder should extend. When we release it, it will retract. And then let's press a push button. This is it extend. As you can see, it's fully extended. Now, when we release this push button, it should retract. This is how we control double 18 cylinder indirect control. We started with a numerical, and now we design it using an electrical control circuit, which is called electro-pneumatic control circuit. So thank you for watching this video. Please check other videos that we are going to design in future to help you understand more how to use this software, and also to be able to design your own circuit. This is just the introduction of this software, how to use Fluidsim. We'll continue doing other videos that will be able to assist you to analyze the circuit and do fault finding. But these are just basics, and I hope they are really helping you to understand how to use or how to design this circuit. Thank you. Stay safe.